have heard about us. If you've heard of Brewer Science, you've heard of us through the semiconductor world. We're a provider of materials and chemicals for the semiconductor processing, wafer level processing, photolithography, hard masks, that so forth, and we've been there for about 40 years. What I'm going to talk to you today about is another business that we've had for about 10 or 15 years, and that's in smart devices and printed electronics. We've taken our know-how in material science and applied that for making sensors and sensor devices. So highlight today is an effort that we're doing in water quality monitoring. So our vision at Brewer Science is to be able to make water sensors small and cheap and low powered enough that we could position them anywhere in the world, scatter them thousands across the space, and monitor our surface water, our lakes, rivers, and streams in real time, right? And track change in our water supply. That's not done today. Right now, everything is done by sampling. Maybe once a week, maybe once a month, but it's a single point in time. A person goes out to a river or a lake, captures a sample or two, takes it back to the lab, a couple days turnaround. Each sample usually costs between $500 and $700, depending on what you're measuring. And you have that single snapshot in time. Now, if it rains an hour later, your water supply is completely different. So right now, there is no inline monitoring system. There's lots of water sensors out there. Water utility plants use them. They're thousands of dollars or tens of thousands of dollars. Ultimately, there's a couple of handheld devices that you can buy for testing your own tap water. But our focus is really in taking this to the next level, creating a smaller system that you could put under your kitchen sink at home and monitor your water supply in your own home. Because once the water leaves a water treatment plant in whatever city you live in, you don't know what happens to that water. In Flint, Michigan, a couple of years ago, is a prime example of that. Even within your own building, the water pipes are completely different. One tap may be fully clean, and another one may have contamination of lead or some other heavy metal. So well systems is another issue. So lab testing is expensive, and we want to simplify that. So we set out to do our effort in water quality monitoring. So here I show a schematic of our system. We have the core of the system is our flow cell sensor, and in here I'll show the picture of the sensor in a minute. Is tied to the mechanical pieces with the valves and pumps and calibration solutions. The water comes in as either a sample or as an input in line and passes across this flow cell, and then we have electronics in here to capture that information. This is our first fully integrated benchtop system with all of the wires and electronics. This is the water sensing array. It's on a rigid material. On here we have a bunch of electrodes. Each electrode we can put a different material on for measuring a different analyte. So in this example, we have an analyte for measuring, or a sensor electrode for measuring nitrate, for measuring lead, and for measuring hydrogen, which is pH, for measuring pH ultimately, temperature and conductivity. This is this is a two-sided board made through additive manufacturing. So this is everything from deposition to sputtering to screen printing. It's a simple process. We start off with a bare substrate and print through each of these steps. Create the flow cell itself, package it into a flow cell system here, and you see the water would come in through this inlet here, run down here, and pass across the electrodes, which I showed previously, and then out.